So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the keyword for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it. Hey guys, and welcome back. We are continuing with Unit 2. We are on Lesson 4. Our aim for today is going to be how do we define and identify proportional relationships by using tables, graphs, and equations. So our warm-up for today, we're looking at two different graphs. Our first one is a proportional relationship, and then on our right we have a non-proportional relationship or not a proportional relationship. So look at the two graphs, see what the difference between the two of them are, come up with a couple of ideas, and then we're going to go over a few of the properties for proportional graphs and different rules for graphing. All right, so rules for general graphing. You always want to make sure you're using a ruler for a straight line. So make sure you use a ruler for straight lines. Second rule, label the axes with units. X and Y. The values on your Y and X axis should be increasing at a consistent rate. So values on axes constant rate. So make sure you show arrows to show continuing lines. And then label your line with the equation. So y equals k times x. What are properties for proportional graphs? So if you look at the proportional relationship on the left, you'll notice that the line or the graph that's on the coordinate plane is linear. So let's talk about the different properties for proportional graphs. If you notice on the left, the proportional relationship, this graph is a line. It's a straight line. So that's one of the conditions. So the graph is a straight line. The other thing that you should notice between your not a proportional relationship and proportional relationship is that your proportional relationship starts at the origin, whereas your non-proportional relationship does not. So the graph must pass through the origin, which is 0, 0. If you notice, this point right here, 1, this would be 5. 1, 5 would be its unit rate. So that's just something good to know. Your unit rate is represented . by 1 comma and then k. And we want to remember that our equation is y equals kx, k times x. All right, let's try the first question. So the relationship in the table represents a proportional relationship between the number of pounds and cost for pasta. Complete the table and then graph the relationship. So we're doing two things. We're completing and then graphing. So if I know that 4 ounces of pasta is going to cost $4.20, then what I can figure out is the unit rate. So 4.20 divided by 4, I'm going to get 10.05, $1.05. So then I can go from there and use the equation to figure out how much 3 ounces and then how many ounces $5.25 will cost get me. So let's say y equals kx, k times x. So y equals 1.05x, and now we can substitute in ounces for x, and y is our cost. So I would do 3 times $1.05. 3 ounces would cost $3.15. Then we have $5.25. How many ounces is that going to be? I can say $5.25 divided by $1.05. That's going to be 5 ounces. And then 6 times $1.05 is going to give me $6.30. So what I'm going to have here is I'm going to put each line on my x-axis. We have my y and my x. My x is ounces. My y is cost. Each line is going to represent a number. So I have 1, 2, 3, 4, 5, and 6 ounces. My cost I'm going to increase by the unit rate, which is $1.05. $1.05. $2.10, $3.15, $4.20, $5.25, and $6.30. Now we're going to plot points. So we have 3 ounces at $3.15, 4 ounces at $4.20, 5 at $5.25, and 6. And draw a straight line. And then my arrow to show continuous pattern, y equals 1.05x. And that's my graph. Let's try number 2. All right, so here's our graph. The graph shows a relationship between distance a car travels and the time in hours. Answer the questions based on the graph. So what point does 10, 600 represent? If I look at that point, 10 comma 600, that's going to tell me how many hours I drove. So in 10 hours, how many miles was covered? The car travels 600 miles. You need to find the constant of proportionality. This is also known as your unit rate per 1. So you can use any point, or you can try and figure out what the unit rate would be on the graph. From the graph, I'm going to use the point 10, 600. So if I have 10 comma 600, I know my y value is going to be divided by my x, which is really 600 divided by 10, which is going to then give me 60. And I need to make sure I have my units miles per hour. And then I need to write an equation, which is basically following the form y equals k times x. My unit rate, my k value, my constant of proportionality are all the same. So all I have to do is take my unit rate and plug it into k. So I have y equals 60x, and that's going to tell me basically how many miles I can drive within whichever or however many hours I want to find out. Number 3, try on your own, come back, and we'll check to see if you have the right answer. So we have to fill in these blanks. I have to fill in the number of days for pounds of food based on this information. Now I have the information. So what if I say every 3 days you get 2 pounds of food? What is the rest of the table going to be? So for number 3, there's some information that you will need to finish the problem. So for here, you have 3 days and 2 pounds of food. For 6 days, there's 4 pounds of food. And for 9 days, there's 6 pounds of food. So you need to figure out how many pounds of food in 12 days, and then you're going to have to graph and then determine if there is a relationship between days and pounds of food, if it's proportional, by the graph. So you have to use evidence from the graph. So pause the video, try this one on your own, and come back and see if your answer is correct. Okay, so you should have figured out that in 12 days, there was 8 pounds of food of dog food. The first thing I want to do is label my graph. So I'm going to say pounds of food. And then the number of days would be my x. This is my y, this is my x, days. And I'm going to label 0, 0. All right, so I know that I have to cover days with 3, 6, 9, and 12. I'm going to increase and go up by 3s. So 3, 6, 9, 12, and I have one more spot, 15, perfect. And then for my pounds of dog food, I'm going to go up by 2s. And I think I can actually skip. So 2. All right, excellent. So I can get up to 10 pounds of dog food. I am going to plot my points. and draw my line out. I want to find my equation, which is really going to be y equals 3 halves x. Oh, 2/3. Whoops. Because this is my x and this is my y. And then how I'm going to justify my answer, if it's proportional or not, by the graph. So yes, the relationship between days and dog food is proportional because the graph is a straight line and passes through the origin, 0, 0. And there you have it. That would be our answer to number 3. The 2 reasons why a graph is proportional is because it's a straight line and it passes through the origin. Here would be your y-intercept. Your y-intercept is always 0 in a proportional relationship. All right, well, that is it. Remember to identify your keyword. Make sure you write down any questions you have for me, and I will see you in the next video. Bye.